Okay, this is number 5, and this is the natural log. Y equals the natural log of x. And again, it's nice to check these with a table of values, and then you can kind of learn what it looks like. And then after a while, you won't have to do this. But it's good to do it a safe way. Now the thing is, if we're trying to find values for the natural log of x, what's the natural log of 2? What's the natural log of 3? We don't know that, so we can change this to an exponential equation. In other words, if I look at this natural log, e is my base. Okay, and y is my exponent, so e to the y equals x. So I can change this from a logarithmic to an exponential equation. And then we can put values in here. Now remember, e, as we talked about before, was about 2.7. So we can use that as an approximation for e, 2.7. And then 1 over e would be about 1 over 2.7, or 1/3. So that's what we're going to use for these approximations. So I just put values in. Now the thing is that I'm not going to put a value in for x and find out what y is. I'm going to go backwards. I'm going to put a value for y in and find out what x is when I do my table of values. So when y is -1, e to the -1 is 1 over e, or 1 over 2.7, or about 1/3. When y is 0, e to the 0 is just 1. And then when y is 1, e to the 1 is just e, which is about 2.7, so I can plot this. Okay, when y is -1, I get 1/3. When y is 0, I get 1, x is 1. And when y is 1, I get e, which is about 2.7, and then I just graph that. So you can get a pretty good graph by using these 3 points, and basically we're going to be using 1/3, 1, and 2.7. All right, and my domain, it looks like x is greater than 0, not equal to 0, greater than 0. It looks like my range is all real numbers. Okay, now this is a little tricky. Y equals negative the natural log of x. So I'd have to take this negative sign and put it on the y first, and then I would change it to an exponential equation. So I would get e to the negative y equals x. Okay? And then when I put this, set up my table of values, I put values in for y. So when y is 1, this is going to be -1. So e to the -1 is 1 over e, or 1/3. Again, 0 gives me 1. When y is 0, that's 1. E to the 0 is 1. And then when y is 1, that's e to the -1. I'm sorry, when y is -1, that's -1, which is 1, so e to the 1, which is just e. So those are my values there. So I can put this in. When y is 1, x is 1/3. When y is 0, x is 1. And when y is -1, x is 2.7. Okay? Now, you know, you could, after a while, you could just realize that we just kind of flip this over the, the x-axis with the negative sign in front. We just kind of flip this over the x-axis, so it's going to give you the same thing. In other words, I put this on the bottom and then on the top. That's what I get. So that's a little bit easier way to do it, but the table of values is a good way to check it. Okay? Let's take a look at this one now. This is, again, I've got this y equals the natural log of -x, so I can change this. Again, this is going to be my, e is my base, y is my exponent, and then I've got a -x over here, and then I just put the negative in front. Okay? And then made a little error over here because I actually kind of flipped this one around the x-axis rather than the original one, which is what I'm supposed to do. So the table of values kind of help check this out a little bit for me. In other words, now we can say when when y is 1, I've got e to the 1, which is just e, so -2.7. When y is 0, again, I got 1, so -1. Okay, e to the 0 is 1, but I got a negative in front of it. And then when y is -1, that's going to be e to the -1, which is 1 over e, which is about 1/3, -1/3. And so when I put these values in, I get, when y is 1, I get -2.7. When y is -1, I get 0. And when y is, when y is 0, I get -1. X is -1. And then when y is -1, x is -1/3. And like I said, now this is going to be flipped about the y-axis when we put a negative sign on the x. So that we know that from our transformations. And like you can see, I made a little error here because what I did was I went symmetrical to the x-axis. I was looking at this, so I kind of flipped this. I didn't realize, I kind of should have gone back to the original. And this is the one you want to kind of flip around the x-axis, and you can see how this is symmetrical. If I put this over here and that over there, it's a little bit easier way to get it, just by kind of making it symmetrical to the y-axis. This makes it symmetrical to the x-axis. Just flip it. And this makes it symmetrical to the y-axis. Okay? And then the last one. For D, all we had was a shift here. Over here, sorry. This was 3 plus the natural log of x. So all we're going to do is we're going to shift it vertically up 3. So here was my natural log of x. Again, as I had graphed from the very first example, this is the natural log of x. And all I did was shift each one of these up 3, and then I get the new function y equals 3 plus the natural log of x. Again, the domain here, x is greater than 0, and all real numbers. Okay? And this domain here, I don't know if I went over this, x is greater than 0, all real numbers, and the range, x here is less than 0, and all real numbers. So there's your domain and your ranges for all the functions. Hope that helps.